In this Algebra 1 video, Chapter 2, Lesson 6, we're going to talk about ratios and proportions. Our objective is, as the student, I can compare ratios and I can solve proportions because I will understand and apply the cross-product property. So hopefully the cross-product property sounds familiar because we may have remembered the cross-product property can be used to solve any proportion. I will come back to this slide. But before we jump into this too far, there's a few vocabulary words we want to make sure we understand. A lot of these will sound very familiar from 7th grade math, especially Chapter 4. So if you need some help or maybe some more understanding on some of these items, what we're doing in one section, Algebra 1, each of those was its own lesson back in Chapter 4 of 7th grade. So feel free to go back and check those videos if you have more questions about some of the things we're going to talk about. So I threw two words at you. I said ratios and proportions. So let's talk about ratios and proportions. Let's talk about some of the vocabulary we want to make sure we're familiar with. Now, there's going to be about 3 slides of vocabulary. A ratio. A ratio is a comparison of two quantities, and we're generally comparing them by division. So, for example, if we're comparing 5 to 8, 5 to 8 can be written as literally 5 to the word 2, 8. Or we can put it as 5 over 8. Notice, the first number is the one that's on top. And we can also write it in colon form to where the number that's on top still comes first. So literally this version and this version, they look exactly the same except we change the word to the colon. So there's all different ways to write a ratio. Now, when you compare two ratios to each other, or two fractions, remember ratio is also a fancy word for a fraction, when you compare two fractions together and you're saying that they're equal, you're using a proportion. And oftentimes, one of the items in our proportion will be unknown. For example, 18 could be x. And in this video, we'll do some examples like that. But a proportion is essentially just some kind of statement saying that two ratios or two fractions are equal. You can write that also sideways. Instead of writing it as 2 over 3, you write it as 2 colon 3 or 2 to 3. In other words, going from this version to this version like we did up there. And then do the same thing for the other side. And so this is also a proportion, but you're just writing it sideways. There's 2 vocabulary words that I think we mentioned, but we didn't make a big deal out of it. I want to make sure these probably sound new. We're going to talk about means and extremes. Now, I'm only mentioning these because there's many times proportions and definitions will often use these words when talking about ratios and proportions, and I want to make sure you know what they mean. In other words, when you write it in this order, meaning the first one colon the second one, equal sign, so in colon format, and you have an equal sign comparing them, the ones that end up on the inside, kind of like the mean or the average is usually somewhere in the middle. In other words, the two middle numbers when you write it in this format. So that means it's the bottom of the left fraction, it's the top of the right fraction. But when you write it sideways like this, they're the ones that end up in the middle. Those are your means. And the ones that end up on the extreme outer limits or the outside, those are your extremes. Those are the ones that end up those are the ones that were the top left of your proportion and the bottom right of your proportion. They're very picky when they name these sometimes, and so make sure you understand which one's which, because like I said, there will be definitions and examples that use these terms. I want to make sure you know what they're referring to. So hopefully this one is hopefully cross-product property is no mystery to you. We used to say it over and over again in 7th grade because I wanted you to feel confident in knowing the cross-product properties used to solve any proportion. I don't care how algebraic and symbol-filled the proportion is, it can always be restated or simplified using the cross-product property, and we will do some examples of that. Because the cross-product property is not only used to solve proportions, it can also be used to verify them. Like let's say we didn't know if these we didn't know if those were equal to each other. We could confirm it with a cross-product property. Now, I understand if you were to do your fraction skills, 18 over 27, divide top and bottom by 9, you would get 2 over 3. So 2 over 3 does equal 2 over 3, so they are equivalent. But I wanted to make sure you realize we can also verify them, especially more complex ones, with the cross-product property. So a few more vocabulary words. Rate and unit rate. Again, these should sound very familiar from Chapter 4 from last year. So now, a rate is some kind of comparison of two numbers, but here's the important part. They will have different units of measure. So an example would be, we went 120 miles in 3 hours. So you can compare that, 120 miles per 3 hours, 120 miles for every 3 hours. But what's important is that it's two different units of measure. That's what makes it a rate. The only difference between a rate and a unit rate is a unit rate, the denominator is a 1. You still are comparing, it's still a rate, so you're still comparing things of two different units of measure, but the denominator will be a 1. So we want to know for per one thing, or for every one thing of the other item, of the other unit of measure. That's what makes it a unit rate. So if you find out, for example, how many miles in 3 hours, okay, that's great. But let's find out how many, you can turn that into a unit rate by finding out how many miles in 1 hour. So in 1 hour, we would do 120 divided by 3, and we would get 40. So the answer to this question, if we want to make it a unit rate, would be 40 miles in 1 hour, or 40 miles per hour. And that's a common unit rate you're used to hearing. So that's an example of what I mean by rates and unit rates, how they relate to each other. Now, our last vocabulary. Anytime you're using, I'll come back to this one actually. Let's first talk about this. In general, there are 3 situations that are proportional, meaning things that we use proportions to solve. And again, these should definitely sound familiar from Chapter 4 from last year. And I keep saying that because I want to remind you, if you need more help with some of these skills, please, and definitely take it upon yourself. Check out those Chapter 4 videos from our 7th grade math section of the channel. Anyways, those situations are rates, such as something changing, something having a speed. For example, let's say you make 4 bicycle seats every 3 hours. So you could say 4 seats per 3 hours, or for every 3 hours. I don't literally want you to write that on top of it. I'm using a highlighter so I can erase it. So that's a rate. We're comparing 2 things in 2 different units of measure. The top is seats, the bottom is hours. Okay? And so, or we can do scale drawings and models. Scale drawings and models are things like maps, model airplanes, drawings or blueprints, but it also could be in the other direction. It could be, let's say, the model of a cell blown up really big so we could see it, or a drawing of an atom. So scale drawings and models are something that we can use that represents something either too big or too small. And that's what should make this one sound familiar, is a rate called a scale is used to make a scale model of something too large or too small to be convenient at actual size. And in other words, if we're describing an atom, we wouldn't be able to point and poke it and label things because it's too small. So we would have a blown up version of it so that we could do that. Now, the actual comparison of how the map compares to the actual, for example, is, let's say 1 inch on the map equal to 100 miles in the actual world. That means every 1 inch is 100 miles. We could use that to now solve questions, and that can also be written as a fraction. But there could be questions like, hey, it's 3.5 inches on the map. How many miles is that in real life? Or it's 240 miles in real life. How many inches is that on the map? Those are some examples that I'm talking about of using scales and scale models. Or I guess in the case of a map, it'd be a scale drawing, not a model. And finally, the third situation that you can use proportions to solve and verify are similar figures. Similar figures are shapes that are the same shape but different size. And it's not just shapes. It technically can be 3-dimensional figures, similar figures. It doesn't have to just be 2-dimensional. It can be 3-dimensional. But it's somehow saying one was like an enlarged or a shrunken down version of the other. Same shape, different size. So now let's do some examples with proportions. So for example, if I said verify ratios, and we can use the cross product property, technically in a lot of these you can just use your fraction simplifying skills, but I'm going to be in the habit of showing the cross product property, so even if something is more complex and maybe it's decimals, you'll be able to do it. Anyways, so to confirm if these ratios do make a proportion, or finding if they are equivalent, we can use the cross product property to do so. So remember, the cross product property means multiplying diagonal in both directions. So 14 times 21, we're going to check to see if that's equal to the other direction. In this case, 3 times 98. So multiply both of these. And if you do that, you end up with 294 equals 294. So it turns out it is true. They are equal to each other. So for that reason, these ratios are equivalent, and yes, they are proportional. That's what we just discovered. So like the example on the right, with it being decimals, it would be a lot harder to try to use your fraction skills to just simplify, like you could have done in the one on the left. So in this one, you're definitely want to make sure you use the cross product property. So remember, multiply both directions, and in this case, we're seeing if it's a proportion, we already know what's on both sides of the equal sign. Normally, you would do this if you were checking to find something that was missing. But in this case, we know everything, so we just want to see if it's true. So 1.7 times 2.4. So multiply those, we'll see if they're equal. So on the left side we get 3.48, and on the right side we get 4.08. Those are very clearly not equal to each other. Therefore, we would say that these two ratios, these two fractions we started with, were not equivalent. They are not proportional. So that's what I mean using the cross product property to check. So now this stuff we're about to talk about should look very familiar. We're going to talk about solving proportions. So for example, if you had a proportional situation, maybe it's set up this way. For this example, we're going to focus on just how to solve it. If you got 4 over 21 is equal to blank over 84. We can solve these using the cross product property. That's what we're going to use. So remember, it doesn't matter which direction you multiply in first. I'm right-handed, so I tend to prefer to go in this direction first, but honestly, it doesn't matter. So that means we have 21 times y on the left side, and then on the right side, we have 4 times 84. Our job is we now are going to have an equation. As soon as we multiply the right side together, we'll have a one-step equation for us to solve. So now we have 21y equals 336. That is a one-step equation. And how do you move all coefficients to the other side? Because we got to get rid of 21. We got to get y by itself. You're going to divide. Remember, when you divide both sides by 21, they're going to cancel on the left side, and you're going to be left with y equals, and do that division, you'll have your answer. And that answer is 16. So you have y equals 16, meaning the blank that went here was 16. Now, this is one of those examples, you may even use your fraction skills and your equivalent fraction skills in order to find out that that was 16, but regardless, I want to make sure you understand the cross product property now, so we do more advanced examples where you start having expressions in some of these blanks, and you'll see what I mean in a moment. We're going to do some of those, you'll be prepared. So now we're going to do an example where you're going to do this yourself. So you try this one. Use the cross product property to solve this one. Now press pause and give it a shot. Alright, hit pause. Okay, we're going to use the cross product property. Multiply in either direction first, it doesn't matter. So x times 1, don't forget to go in the other direction. I just use two different colors so you can see what comes from where. And now those will always be equal to each other. Multiplying in one diagonal direction will always equal multiplying in the other diagonal direction. The left side equals 1x, or just x. And the right side, 7 times 6. You say I forgot what is 7 times 6, and you're all done. And so this one ends up being x equals 42. Now notice, we didn't have a coefficient that we needed to divide out of here. That's because we did 1 times x, and our coefficient was 1, so we didn't need to worry about it. So you got lucky on this example, but in general, sometimes that'll happen. So in this proportion, we're gonna solve it using the cross product property, but notice it's not as simple as just having a letter here. We now said that blank is x minus 5. Now remember, anytime you're solving for one of these 4 positions, you're always going to use the cross product property. Even if you weren't doing that, you could still at least simplify or rewrite it in any proportion with the cross product property. Alright, so to do this, we're going to do the same thing. We're going to multiply in both directions. So this way we're going to have 15 times 4. Now I'll go in the other direction. But notice, you have 10 times all of that. You have 10 times x minus 5. So you're going to want to put x minus 5 in parentheses because it's 10 times all of it. So x minus 5. And now those will always be equal to each other. You now have an equation for you to solve, but your job is, just like any equation we've learned, we've got to simplify this right side and get rid of those parentheses first. So what's that property called you would use here? That's the distributive property. So you're going to do 10 times x, and then you're going to do minus 10 times 5, or technically negative 50 is what it would end up being. And if you're not sure, think about a positive times a negative. Well, that's a negative. And so you use the distributive property on the right side, you end up 10x minus 50. And then on the left side, 15 times 4, that equals 60. And now look what you have. You now have a two-step equation. All you got to do is solve this two-step equation, and you'll have your final answer for the value of x. So just like any other two-step equation, let's get x by itself. So let's move this minus 50 to the other side. And I moved it up here so I'd have room. So then we're left with 110 equals 10x. Now you just have one step remaining. You just need to get that 10 out of there. So we're going to divide both sides by 10, and you'll have your final answer. And you'll have 11. So that means x equals 11. So notice, this one would have been a lot more difficult for us to solve without the cross product property, especially if, God forbid, what was in here was even more complex than what we had. Or even sometimes this would also work, especially if you also had an x here, or if you also had an x over here as well. Sometimes you can have variables in more than one position, and you want to use the cross product property to help you set up into an equation that you can solve. So what I want to point out was, remember, the key thing of what we did here is when we multiplied both directions diagonally, when we went this way, we had to use the distributive property so that it was 10 times all of the x minus 5. Okay, so now I want you to try. I want you to solve this proportion using the cross product property. Hit pause and give it a shot. Alright, so we're going to use the cross product property. Go in both directions. 7 times 36, well, that's going to equal the other direction. X plus 9 times 21. So it's 21 times all of x plus 9, so we probably should put x plus 9 in parentheses and have that multiplied by 21. Those will always be equal to each other. Now you're going to have to use the distributive property to see what the right side equals. And then once you'll do that, you'll be able to also multiply the left side, and you'll have an equation ready to go. And you'll end up with 252 equals 21x plus 189. So now you have a two-step equation. You're going to use your equation skills now to solve it from here. We're going to subtract 189 from both sides. And then we're going to divide both sides by 21. We end up with x equals 3. That is the value that would make our proportion true. You'll notice that in this video we've primarily focused on first some definitions of situations that are proportional, and then we've primarily focused on our examples, how to solve proportions, because I'm hoping that we're going to remember how to set up proportions when they're not given for word problems. But that's something we can also practice in class. But that's going to be using a lot of the skills we talked about last year from 7th grade. We did a lot of practice with it. So again, refer back to your materials or those videos if you need some more help on how to set up the proportions if you have some difficulties with that. I'll make this our last example. You're going to try to solve this proportion, and I suggest you use the cross product property in order to solve it. Alright, press pause and try this one. Okay, you're going to use the cross product property to multiply in both directions. And so do this in both directions and write it neatly. So yeah, you'll have to use the distributive property on both. But take your time to write that out and be careful. So when you write it out, it should look something like this. So now you're ready to use the distributive property on both sides, and then you're ready to start solving. So now you have an equation with a variable on both sides, and just use the skills we talked about earlier in this chapter to help you solve that. If you chose to move your x's all to one side first, you'd end up with 50x plus 30 equals 70. So now you have a two-step equation, and solve it from here. And you end up with x equals 4/5 or x equals 0.8, depending on what format you wanted your answers in. Alright guys, so we talked about all the different situations that are proportional, and we spent some time doing some examples with the cross product property to solve proportions. So make sure you come to class ready to apply it, and again, remember, if you see word problems that you're having a hard time setting up yourself, we'll do them in class and talk them out, but also if you need more, spend some more private think time, you can watch our videos from 7th grade where we had a lesson on every type of proportional question. Good luck.